Alright, today we're going to talk about matrix multiplication. You're going to need to know a few things about it. I'll try to make it as simple as possible. It's not all that complicated. You can multiply a single number through a matrix. So if you get something like this example at the top, where they have this 3 on the outside of the matrix, it's real simple. You're going to multiply the 3 times every entry inside of it. So that's one type of matrix multiplication. It's called scalar multiplication. You just take a number and you multiply it through all of the elements of the matrix. We have scalar multiplication properties, again, that you're going to need to know. Closure property, again, is just telling you that it's a matrix. Okay, you're not going to use that or anything. You guys remember the associative property? That's where order doesn't matter. Well, this one, no. Order doesn't matter. The parentheses, right? So what's happening here is this. A is your matrix, and C and D are some scalar numbers. Then scalar is just fancy for it's a number that you're going to multiply through. Okay, scalar, you're changing the scale. That makes sense? All right, so you can multiply those two numbers outside the matrix together first and then run them through the matrix, or you can multiply one number through the matrix and then multiply the second number through the matrix. It's just basic math stuff. You got your distributive properties. You guys know what the distributive properties are. Identity property, whenever you multiply times 1, it stays the same. And then this is the multiplicative property of 0, which just states anytime you multiply something by 0, you get 0. Now, do you guys remember what this 0 represents right here? When we're talking about matrices? The 0 matrix. 0 matrix just means it's a matrix with zeros as all of its entries. So that was from 12.1 as well. Okay? All right, now, matrix multiplication. This is going to be a tad different than what you're used to if you haven't seen matrices before. In order for you to be able to multiply matrices together, the columns of the first matrix have to match up with the rows of the second matrix. Now, here's the easiest way of doing it. Okay, if you write out the dimensions of a matrix, okay, what's the dimensions of this first one? 2 by 2. What's the dimensions of the second one?
2 by 2.
It's a 2 by 2 also, right? The only way you can multiply two matrices together is if these numbers are the exact same. Okay? So if they're the same, then you can multiply. And the resulting matrix is going to be what's left on the outsides. So if I multiply a 2 by 2 times a 2 by 2, I'm going to end up with a 2 by 2. Okay? If I multiply a, I don't know, give me a matrix. 2 by 4? If I multiply a 2 by 4, and then give me another one that's got to be, no, it's got to be, what has to, so it has to be a 4 by something.
2 by 6. Oh, 4 by 6.
All right, a 4 by 6. Okay? You see how these numbers are the same? If they're not the same, you say not possible. You can't do it. Okay? This is going to result in a 2 by 6 matrix. Now, here's how you do this. And this should make sense logically if you pay attention to how this works. What you're going to do is, I'm going to take this, you guys know what the numbers mean? First number is, it's the address. First number is row, second number is the column. So this is row 1, column 1, row 1, column 2. Row 2, column 1, row 2, column 2. What you're going to do is you would take A11, I'll write green. You would take this first row, you would flip it vertically, you would multiply across and then add them together. So think about it like this, okay? If I take my row 1 and I multiply it times my column 1, that information is going to give me row 1, column 1 in my new matrix. Okay? And then I just multiply times the next column. If I multiply row 1 times column 2, it's going to give me row 1, column 2. And then once I run out of columns, this will make more sense when I get numbers, so we'll see it in an example in a second. Once I run through all the columns, then I take row 2, flip it vertically, and I do the same thing and go across. So when I take row 2 times column 1, I get row 2, column 1's entry. When I take row 2 times column 2, I get row 2, column 2's entry. So it makes more sense when we have numbers and you can see it played out. But that's how this works. Here's this. All right. Dimensions of a product matrix, we pretty much already talked about this, but this first one here is a what?
3 by 2.
This one's a 3 by 2. And this one is a 2 by 4. Can we multiply the two together?
Yes.
We can multiply the two together, and what should we get? A 3 by 4. So that's at least an easy way of determining whether or not you can even multiply them together. Okay? Everybody good with that? Now you guys understand, here's why this works. Okay? The reason why those two numbers have to be the same is, remember, what we're going to do is we're going to take row 1, which is 1 and 2, right? Okay? And we're going to make it vertical right here. 1 and 2. Okay? So you guys know it's going to be a 3 by 4 matrix. Everybody's good with that? Here's how this works. When I take 1 times 7, I get what?
7.
And 2 times 11 is?
22.
And what's 22 plus 7?
29.
29. Okay, I multiplied row 1 times column 1. I got my row 1, column 1. And now I go to the next one. What's 1 times 8? 2 times 12? 24 and 8 is? 32. Remember, this 1 and 2 is row 1, so everything I get should be on row 1 until I'm finished. Okay? And so if I kept going, you'd have 9 and 26, which is 35. You'd have 10 and 28, which is 38. And then I ran out, right?
Yeah.
Okay, what I would do next is I would take the next row, 3 and 4. And I would do the same thing all the way across. Now it would give me all my second row until I run out. And then I would get my third row. Does that make sense?
Yeah.
So for this one, if you were doing this one, you would say 3 times 7 is 21, 4 times 11 is 44, and 44 and 21 is 65, right? So it'd be 65. And then I would just keep going. You get the gist of it now?
Yeah.
And then after I finished up all of those, I would put 5 and 6 there, and I would go all the way across. Now I've run out of rows, so I'm done. I have a 3 by 4. The reason why the two numbers in the middle have to be the same is because when I take this row and I flip it vertically, I have to be multiplying it times something. I can't have any extras. And so the only way that works is that these two numbers are going to be the same. Okay? Okay, so one thing that we have to make very clear is that order does matter, because we can multiply the 3 by 2 times the 2 by 4. But if you flip it around, you can't multiply the 2 by 4 times the 3 by 2. Because those middle numbers aren't the same. Okay, one's a 4, one's a 3. That would mess everything up. So multiplication of matrices is not going to be commutative like all of our regular numbers in multiplication. Order does actually matter. So the very first thing you should always do when you're doing matrix multiplication is write down the dimensions and check to make sure that those middle two numbers are the same. The rows or the columns of the first have to match up with the rows of the second. Okay, properties of matrix multiplication. Again, they're just telling you that A times B is going to be a matrix. Close your property. Here, A, B, C, and then they just change the parentheses, right? That's the associative property. You're changing your association. The distributive property, you multiply 1 times the first and then times the second. It's the same thing. Okay. Here the order does matter on this, so the first one and the second one don't necessarily mean you're going to get the same solution. Right? So make sure you know that. And anytime you multiply by the 0 matrix, you're going to get 0, because if you multiply anything times 0, it comes out to be 0. So all of your entries would be 0. Okay. All right, now, this says find each product, sum, or difference. So we have 4 of them to do here. The first 2 are pretty easy. All we're going to do for number 1 is what? Yeah, you're just going to take 2 and multiply it through all the entries in D. And so that's going to come out to be what?
2, 0, 0, 2.
Okay, pretty simple. All right. Number 2, all you're going to do is what? Yeah, you're just going to multiply 1/4 times everything in C. So you're going to get 3/4. I don't know if I did this. Negative 3/4. Negative 1/4. 1/2. Yeah, 1/2. Negative 1/2 and 1. So those are easy. The scalar multiplication ones are pretty easy. We just multiply them through. You don't have to check anything there because you're just multiplying through. Okay, this one down here at the bottom is D times C. And so you've got, and I always just write it up here. So D is a what by what matrix? A 2 by 2. And then C is a 2 by 3. And so we should end up, our answer should be a 2 by 3. Okay? order matters, so I'm going to take the D rows and I'm going to multiply them times the C columns. Okay? So I'm going to take 1, 0, and I'm going to put it right here. And this is going to give me row 1. Because that's what I'm multiplying by, is row 1. Okay. 1 times 3 is 3. 0 times 2 is 0. So pretty much we're just going to run the 1 to the top. Right? It's 3. What's the next one going to be? Negative 3 and negative 1. And then we ran out of columns, so we go to the next row. The next row is what? 0, 1. I like to use different colors so I don't get mixed up, right? So this one, the 0 is going to cancel everything on the top, so really we're just left at the bottom, right? So what's going to be the bottom, the second row? Okay. And did we end up with the 2 by 3 matrix?
Yep.
We did. That's our solution. That's all you had to do on that one. Now it was a little bit easier because we're multiplying by zeros and ones. Right. Okay, number 4, you're going to multiply 2 times A and 4 times D, and then you're going to add them together. So first of all, the only way we can do that is if A and D are what? Same dimensions, right? They are, right? Okay, so if I multiply 2 through A, 2, negative 2, 6, and negative 4. Okay, and I'm multiplying 4 times D is 4, 0, 0, 4. Everybody good with that?
Yep.
Okay, now all I have to do is add these two guys together, so I'm going to end up with another 2 by 2. What's 4 plus 2? 6, negative 2, 6, and 0. That's it. So not very difficult math. We talked a little bit about matrix equations in 12.1. I mean, it's pretty much just doing algebra with matrices. So the first thing we're going to probably want to do here is what? Yeah, we're going to distribute that 2 through. And so you're going to end up with 0, 2, 6, and negative 8. Okay, now, what would you do next if this was algebra? You would subtract this matrix to the other side, right? Okay, so I'm going to take this guy, and I'm going to subtract him over here. And remember, when we're subtracting it, one way that I think is best, and we talked about this a little bit, is a lot of people forget to run the negative through everything. So if you wanted to, you could make this addition, right? And then change the signs of everything inside. Then you just know you're adding them together. That, people just make little mistakes like that. You mess up one little entry in your matrix, the whole thing is wrong. So whatever's going to make it easier for you that you don't miss it. All right, what you're going to be left with is negative 3x equals 9 plus 0 is 9. Negative 6 plus negative 2. 1 plus negative 6. Good. Negative 2 plus 8. All right. Okay. What would be the next thing that you would do? Yeah, and because we're doing matrices, yeah, a lot of times people will multiply by negative 1/3 just because it's a matrix, right? So if we do that to the entire thing, then you're going to get x by itself. So now pretty much all we're doing is dividing by negative 3, but when we write it as a fraction, we can leave our answers as fractions. Okay? So this first one, what's 9 times negative 1/3? But negative 8 times a negative 1/3 is positive 8/3. Negative 5 times negative 1/3, positive 5/3, and 6 times negative 1/3 is negative 2. And that's it. You found the missing matrix. Okay. I still think the best thing to always do is write down the dimensions so you know if you can do it and what you should expect your outcome to look like. So what are the dimensions of this? 2 by 2, and this is a 2 by 2, so you should get a 2 by 2. Okay? So, what you're going to do is you're going to take the first row, which is 2, negative 1, and we're going to put it right here, and we're going to multiply, add, multiply, add. Okay? So, what's 2 times 0?
0.
What's negative 1 times negative 3?
3.
What's 0 plus 3?
3.
It's 3. That's row 1 times column 1 is row 1, column 1. And then we go to the next column. What's 2 times 4? 8. What's negative 1 times 1? And 8 plus negative 1 is 7. And we ran out of columns to multiply by, right? And so once we run out of columns, we go to the very next row, which is going to be 5 and 3. And what's 5 times 0? 3 times negative 3. And what's 0 plus negative 9? 5 times 4? 3 times 1? And what's 20 plus 3? And we end up with our 2 by 2 matrix, and that would be your solution. Everybody get it? Okay. Okay. What is this?
1 by 3.
A 1 by 3.
Oh, and a 3 by 1 it is.
And what's this?
3 by 1.
What should we end up with?
1 by 1.
What's a 1 by 1 matrix?
0.
No, it's a matrix with 1 entry. Here's what you do. You're going to take row 1, which is the only row you have, 2, negative 1, and 6. And you're going to multiply it times column 1, which is the only column it's got. And you're going to get your 1 by 1 matrix. What's 2 times 2?
4.
4.
1.
This is going to be negative 1 times negative 1 is 1. 6 times 6 is,
36.
and we add all of this together, and you get 41. That's your 1 by 1 matrix. The other thing too, this is important, this might help you out as well. You guys notice the middle numbers that are the same? Right?
Yeah.
Two, like, what I'm talking about is this right here. These are 2s, right? Right? This right here, these are 3s. Okay, those numbers that are in the middle that have to match up are always going to tell you how many numbers you're adding together to get each entry. I have to add 2 numbers together to get each entry. I have to add 3 numbers together to get each entry.
And then the outside ones tell you what your next one.
That's going to tell you what your dimension is going to be for your final matrix. So if that helps you out too, then that's another way of looking at it. Is whatever those numbers are in the middle, that's how many I should be adding each time for each entry in my matrix. Okay, here, you've got a carpenter builds 3 boxes. One box uses 12 nails. The second box uses 6 nails and 6 screws. The third box uses 8 screws and 2 hinges. Nails cost 4 cents each. Screws cost, what does that say, 6 cents each? Hinges cost 12 cents each. They want you to write a matrix to show the number of each type of hardware in each box, and then write a matrix to show the cost of each type of hardware, and then find the matrix showing the cost of hardware for each box. Sounds complicated, right?
Yeah.
Okay, all you have to do is this. It's not super complicated, but you've got 3 boxes, right? And so what you should do is you should label each column to represent some piece of hardware. So like this could be, column 1 could be like nails, and then screws, and then hinges. Okay? That make sense so far? Okay, so in the first box it uses what? 12 nails, right? So how many screws did it use?
0.
How many hinges?
0.
Okay, that's not too difficult, right? And then in box 2, it uses what? 6 nails, 6 screws, 0 hinges. And the last box uses 0 nails. Is that good? Everybody good so far?
Yes.
Okay, yeah.
And you can do it the other way, right?
Yes, if you do it the other way, then you just got to make sure you order your matrices right. But yeah, you could. Okay? So nails, screws, hinges. Okay? The reason why I do it this way too is if you're doing like X, Y, Z equations and you were taking an equation and then throwing them into matrix form, this is the way that you would do it. So we did this earlier in pre-calc. All right, so nails, screws, and hinges, right? That's a 3 by 3 matrix. Okay? And so the next thing that they want us to do, because they want us to show the number of each type of hardware in each box, that's this one right here. Everybody good? So A, we've done. B says, write a matrix to show the cost of each type of hardware. You want to do a 3 by 1?
Yeah.
Okay. So if you want to do that, then how much does it cost for nails?
4 cents.
4 cents, like this. How about the screws?
0 cents.
And then how about
12 cents.
Okay. So there's a matrix showing the cost of each type of hardware, and it says find the matrix showing the cost of hardware for each box. So don't you have to multiply it?
Yeah.
Okay. So it says for each box, we have a 3 by 3 times a 3 by 1. We're going to end up with a 3 by 1, right?
Yeah.
Which makes sense because it'll be box 1, box 2, and box 3.
Yeah.
Okay? So we would multiply these two together to get our new matrix. What is 12 times 4 cents?
40 cents? Wait, just kidding.
12 times 4 cents? 48 cents? 48 cents? Wowzers.
30 cents?
What that's telling us is this. In order for you to build box 1, it's going to cost you 48 cents. Right? The next one, do you guys want me to take these numbers and flip them? Is that easier for you? Okay, here's what we did. We took 12, 0, and 0, and we ran it through, and we got 48 cents. Okay, 12 times 4 cents is 48 cents, then 0, and then 0. We added them together. All right, the next thing that you would do for box 2 is you would take 6, 6, and 0. So that would be 24 cents and 36 cents. 24 and 36? 60 cents? Right?
Yeah.
60 cents.
I got like 70. Get on my level.
And last,
0,
0, 8, and 2. 8 times 6 is 48, and 24, what's 48 and 24? 72. And so, you can look and see what the cost of your 3 boxes are going to be. Okay? Or, not the cost of each box, the cost of the hardware to make each box. Alright? Easy. All you have to do here is determine whether or not the product exists. So, number 1,
Yes.
Yes.
No.
okay, wait, hold on. A 2 by 2 and a 2 by 2, you can always do that, right?
Yeah.
If they're the same dimensions, you can always do it.
No.
Q is a what?
2 by 2.
That's a what?
2 by 1. 2 by 1.
2 by 1, and S is a,
2 by 2.
can you do it?
No.
What's P? What's R? 1 by 2, can you do it?
No.
No. What's Q?
2 by 1.
2 by 1, what's R?
1 by 2.
1 by 2, can you do it?
Yes.
And what would you get at the end?
A 2 by 2.
A 2 by 2.
So
Homework.